Good afternoon. I'm Navneet Kaur Randhawa, lecturer in IT department from GPC Amritsar. Today I am going to explain the topic of network architecture in computer networks. So in today's lecture the contents are, first of all I'll explain what is the network architecture. How can we use this network architecture in computer networks? After the introduction, the next topic is Ethernet specifications and the standardizations. In Ethernet, there are the different type of categories available. One is the baseband and second is the broadband. After Ethernet, there is one another specification, that is ARC-net, that is Attached Resource Computing Network. After the Ethernet and ARC-net, there is another topic, that is Introduction to Media Connectivity, in which I am going to explain the leased line, then ISDN, PSTN, RF, VSAT, IPLC. So first of all, what is computer network? As we all know, the computer network is basically the interconnection of different computer systems in such a manner that so that we can share the different resources, different information. So computer network is an interconnection of independent computer systems in some manner. Through the some communication media, we can attach these computer systems through some wired or wireless media, so that we can share the resources like some hardware, software, or some peripheral devices. So what is the network architecture in computer networks? So network architecture is simple the layout of that computer network. So a network architecture is the blueprint of complete computer communication network, which provides a framework and the technology foundation for designing, building, and managing a communication network. So network architecture is simply the layout of the complete computer network, how we can design and build and we can manage all these computer network system. It is basically the layered structure. As we know, the computer network is basically the layering architecture. So layering means it is the modern network design principle which divides the communication task into the number of smaller parts. So each part accomplishing a particular subtask and interacting with the other part in a small number of well defined ways. So layering structure means every layer has their own responsibility and their features. So every task is divided into their subtasks. So it is very easy to handle a complete task because it is divided into subtasks. So every layer have to perform their subtasks completely and interact with the other in small number of well defined manners. There are different network models which are used. TCP/IP network architecture is the open network architecture and it is adopted as the worldwide network standard. So TCP/IP is the layered architecture. It is the basically drive. We can say OSI model is the framework, and after the OSI model, TCP/IP model is used as the network architecture. So in TCP/IP, different layers are available, and we can use those layers. There are the several types of network architecture that have been proposed to interconnect with the computer system. There are different standard organization which give standards in computer network. The first of all, as we all know, OSI model is the reference model, or it is the framework which was given by the ISO, that is the International Standard Organization. So OSI model means open system interconnection. The another standard organization is IEEE. IEEE is the Institute of Electrical and Electronics Engineer, and it also gives these standards. So in 1985, the Computer Society of IEEE started a Project 802. Project 802 is to set the standards to enable the intercommunication among the equipment from the variety of the manufacturer. So we can say Ethernet is the IEEE standard, and it is defined the Project 802. The Institute of Electrical and Electronics Engineer is the standardized organization that provides the standards for the networking. IEEE has given many standards for the LAN. So local area network is we are using, and there are many standards which are given by the IEEE. So the first standard, that is the Ethernet, that is IEEE standard 802.3. What is the access method which is basically used in Ethernet? That is the carrier sense multiple access and collision detection, that is CSMA CD-LAN. What is this access method? In this, any station can send the frame on the shared channel. So a single channel is shared by the different stations. So any station can send the frame on that shared channel. After sending the frame, the station carefully monitor that the media monitor the media to check that transmission is successful, completed or not. If the transmission is completely done, that means all goes well and it finished the transmission. But suppose there is some collision occur on the channel, because it is the shared channel, so the station has to send the affected frame once again. So because it is the shared channel, so collision may can occur because of the shared channel. So the station which sent that particular frame, they has to send that affected frame once again. So what will happen second time? To reduce the collision probability for the second time, the station holds itself back from resending the frame for a random amount of time. So more the station waits, less the chance for the collision happening again. So in this case, collision detection multiple access and carrier sense multiple access and collision detection, the single channel is shared by the stations, and whenever the station send the information or frame, it will monitor the media to see that transmission is successfully completed or not. If it is completed, then it's okay. If the collision occur on the channel, then station has to send the affected frame once again. And to reduce the collision probability, the station holds itself for the second time for the random amount of time, so that more the station wait, less the chance of collision happening again. Now this is the Ethernet. Ethernet having the four main standards, that is, first is the standard Ethernet, which is called the traditional Ethernet. The difference is in the case of the data rate. So in standard Ethernet, the data rate is 10 Mbps, that is megabits per second. Next is the fast Ethernet. Fast Ethernet means the data transfer rate, data rate is increases, that is 100 Mbps. Third is gigabit Ethernet. It is 1 gigabit per second. Next is the 10 gigabit Ethernet, that is 10 Gbps. So these are the Ethernet types, we can say. In this, first of all, the Ethernet is the LAN architecture, and it is specified by the IEEE 802.3, and it defines two different categories. Those categories are, first one is baseband, and second is the broadband. Now what is baseband and broadband? Baseband uses the digital signals, so it is using the Manchester encoding, while the broadband using the analog type of signal. So in this we use PSK encoding. So baseband is basically concerned with the digital signals. So baseband is further divided into these standards. First standard is 10 base 5, 10 base 2, 10 base T and 10 base F. Now what do you mean by 10 base 5? 10 base 5 is the type of category or the standard of baseband. So the standard Ethernet, that is the traditional Ethernet, having the common implementation. We can implement that traditional Ethernet in the four type. First is 10 base 5. In this 10 base 5, you can use the bus topology. It is also known as the thick coaxial. Next, second is the 10 base 2. In this also the bus topology is used. Then is it is also known as the thin coaxial. Now 10 base T means the UDP, that is twisted pair, unshaded twisted pair. So in this star is used. Next is last is fourth one is 10 base F, that is the fiber optics we can say, and the star is topology is used. So this is the traditional or standard Ethernet implementation. Now what do you mean by the syntax that is basically used, that is 10 base 5? If in this 10 base 5, the first number, that is 10, that specify the data rate in Mbps, that is the data rate. So data rate is 10 means 10 Mbps, so it will specify the data rate in Mbps. Next is the base or broad, that means the signaling method. So it is the baseband or broadband. If it is base, that means it is concerned about the digital signal and it will handle the Manchester encoding. But if it is broadband, that means it is including the analog signals. Last is the 5, that means the maximum segment length. Suppose it is 5 2, so if it is digit, that means the maximum segment length. Suppose there is given T F, that means the cable type, twisted cable, fiber cable. So this is the complete syntax of Ethernet, that is 10 base 5, 10 base 2, 10 base T, 10 base F. So this is the syntax of Ethernet. Now each device on the Ethernet network, which include computer, some printer or any other device, has their own network interface card. So network interface card normally fit inside the device and it is the 6-byte physical address for the station. Each type of these cables have different operating speed and they will support the different number of nodes per segment and has different maximum length per segment. So every cable have their own features. They are depend upon their different operating speed, different number of nodes per segment. They can handle different maximum length. So every cable have their own features. This is the table in which IEEE 802.3 cable types are explained. There are the 4 main column, that is the fields are there. The first one is the name, second is cable, maximum length of the cable segment, then the nodes or the segment. First one is the 10 base 5. It will also known as the thick coaxial, and maximum cable segment length is approximately 500 meter, and in case of node and segment, 100 nodes and segment we can handle. Second is the 10 base 2. 10 base 2 is also known as the thin coaxial, and 185 meter maximum length, then the 30. Third one is the 10 base T, which is the twisted pair cable. Approximately maximum length is 100 meter, and in case of nodes and segment the value is 1. Last is the 10 base F, that fiber optics. Approximately maximum cable segment length can approximately 2 kilometer, and the 1 value in case of node and the segment. So fiber optics is most efficient and fastest cable, and it is also very expensive. Now first one is the 10 base F, 10 base 5. So 10 base 5 is the original Ethernet system that support the 10 megabits per second transmission rate over the thick coaxial cable. The 10 base 5 identifier is the shorthand for the 10 megabits per second transmission rate, and baseband form of the transmission. Baseband means it is concerned about the digital signals, and in this the Manchester encoding is used, and approximately 500 meter maximum length it can be handled. So it is the 10 base 5. Here 10 base 5, the 10 means the 10 Mbps is the data rate, base means the baseband in which the digital signal can be used, 5 means the 500 meter maximum length of this cable. So this is the syntax of 10 base 5. How we can implement this 10 base 5? In this diagram, the different devices are attached with the thick coaxial cable, which is having the maximum 500 meter range. So cable, this is the cable's one end and another end. So single cable is used and the different devices are attached. So in this 10 megabits per second is the data rate, and we can use maximum length is the 500 meter approximately. Next, second is the 10 base 2. 10 base 2 support the 10 Mbps transmission rate over the thin coaxial cable. It is also known as the thin Ethernet. So in 10 base 2 this type of cable is used. In this 10 base 2, 10 is the data transmission data rate, that is 10 Mbps. Baseband, as we know, the baseband type or digital type of signal. 2 means approximate maximum length is 185 meter. How we can implement this 10 base 2? This is the example in which the 10 base 2 type of cable, that is the thin coaxial cable, is used, which is having the 185 meter length. So different devices are attached and we can use this type of cable, and maximum length is the 185 meter. So this is called the thin coaxial cable. Next is 10 base T. 10 base T supports the 10 Mbps transmission rate over the two pairs of category 3 or better telephone twisted pair cabling, and it is also known as the voice grade twisted pair. In 10 base T, we can use the one pair of wires for transmitting data and another pair for receiving the data. So in this, the two pairs of wires are bundled into the single cable. That may include two additional pairs of wires which are unused for the 10 base T. So 10 base T is the twisted pair cable. So in twisted pair cable, we having the two type of wires which is used. So one pair of wires for the transmitting data and another pair of wires for receiving the data. So these two pairs of wires are bundled into the single cable. So this is the 10 base T. In 10 base T, we can use some connecting device, that is the hub, and the simple maximum segment length we can handle is the approximate 100 meter. So hub, which is used as the connecting device, have the function, and it is also included the repeater with some additional feature. As we all know, the repeater is basically the hardware device which is used for regenerate the bit pattern before it's sending to the another station. So in this, the few cable problems are available, so it is easy to troubleshoot than the coaxial cable. So maximum length we can handle in this 10 base T is the 100 meter. In this 10 base T, that means the 10 Mbps the data rate, and base means the baseband which is of the digital type. T means the cable type which is twisted pair. So twisted pair approximately 100 meter we can handle. So this is the example in which some connecting device hub is used, in which the T type of connectors are we can use, and the different computer systems are or different devices are attached. We can attach this by the two pair of UDP cables. So this is the 10 base T implementation. Last is the 10 base F. As we know, it is the fiber optic type of cable, so it is most efficient and fastest cable. It is also very expensive, so this type of cabling is preferred for running the networks between the different buildings or between the different organization. Fiber optic maximum length can handle, that is approximately 2 kilometers, so it is most efficient and fastest, but because it is fastest cable, so it is also very expensive. In 10 base F, the different field are available. First is the data rate, then baseband, then F means the type of cable, that is fiber optics. So the some connecting device is used and the two fiber optic cables are attached. So different computer systems are attached with the 10 base F type of cable. So this is the implementation of 10 base F. Now the next topic is Ethernet electrical specification. Various electrical specifications for Ethernet are given. First of all, the signaling. What type of signal we can handle with the Ethernet? We can handle two types of signal. One is the digital and second is analog. So baseband system use Manchester digital encoding method so that we can handle the digital signals, while the broadband system uses the analog type of signal, so it is using the differential PSK encoding. Second is the data rate we can handle with the Ethernet. So Ethernet LAN support a data rate between 1 Mbps to approximate 100 Mbps. So this is the data rate we can handle with the Ethernet LAN. Next is the frame format. There are the various fields are available in the frame format. First is preamble, then start frame delimiter, destination address, source address, length, and the actual data, and we can extend that data with some padding data. Last is CRC, that is error correction and detection method. This is the frame format of the Ethernet. In this, first field is preamble, which is of 7 byte. Second field is start frame delimiter, which is of 1 byte. Next is the destination address, which is of 6 bytes, source address 6 byte, length of payload data, that is 2 byte, actual data which is of variable length, CRC method, that is the error detection and correction method, which is of the 4 byte. So this is the frame format of Ethernet, in which preamble is the 56 bits of alternative zeros and 1, which gives the alert message. Start frame delimiter, which is specify the starting of the frame. Now I am going to explain the each field of the frame format. First field is preamble. So it consists of 7 bytes. The preamble is an alternative pattern of zeros and ones that tells receiving station that frame is coming. So it gives the alert message to the receiving station that frame is coming towards them. So it is a collection of alternative zeros and ones, and it is of the 7 byte. So it provides the means to synchronize the frame reception portion of receiving the physical layers with incoming bit stream. So it is gives the alert message to the receiving station that some information or some frame is coming. So that frame contains the alternative patterns of zeros and ones. So preamble is basically the alert message. Second is the start of frame delimiter, SFD. It consists of 1 byte. It is an alternating pattern of zeros and 1, which is ending with the 1 bit indicating that the next bit is the leftmost bit in the leftmost byte of the destination address. So start frame delimiter is basically concerned with the destination address, which is the next field. In destination address, we have to specify the address of the destination which is basically the receive the frame. So destination address, it can be individual address, it can be group address. So it totally depend upon the value of a destination address. So it consists of 6 bytes. The destination address field identifies which station should receive that frame. In the destination address field, the leftmost bit of the destination address is indicate that whether the address is an individual address, means that destination address is individual if the leftmost bit in destination address is 0. If it is 0, that means it belongs to the individual address. If it is 1, that means it is for the group address. So the leftmost bit in destination address field indicate whether the address is an individual address if it is 0, or group address if it is 1. So the second bit from the left indicates whether the destination address is globally administrated or locally administrated. So if the value of a second bit from the left is 0, that means it is globally administrated. If it is 1, that is locally administrated. So the remaining 46 bits are uniquely assigned value that identify the single station and defined group of stations or all stations on the network. So this is the destination address, and the leftmost bits and the next bit of the leftmost bit is very important, which will indicate that the address is belonging to individual address or group address, or it is globally administrated or locally administrated. So values of leftmost bit is very important. Next field is the source address. It consists of the 6 bytes. Source address field identifies that the sending station. The source address is always an individual address, and the leftmost bit in the source address is always 0, because always source can send the data, so it will be individual address. Next field is the length or type. It is the of 2 bytes, and it describes how many bits are present in the data field. Next is the actual data. It is the actual information or actual data. So is a sequence of n bytes of any value where n is less than or equal to the 1500. If the length of a data field is less than 46, the data field must be extended by using or by adding some filler or pads sufficient to bring the data field length to the 46 bytes. So we can extend the data field by adding some extra data, and we can extend it to sufficiently to bring the data field length up to 46 byte. Last field in the frame format of Ethernet is ERC, which is consists of the 4 byte. This sequence contains 32-bit cyclic redundancy check method value, which is indicating by sending the sending MAC and recalculated by the receiving MAC to check for the damaged frames. CRC is basically the error detection and error correction method. It will check the frames which is sent and recalculated on the receiver side, so that we can easily check there is some error or there will some frames are damaged during the transmission. If such thing is happened, we can have to detect that error and we have to correct that error. So this is the field which is basically do this job. After the Ethernet, that is the traditional or standard Ethernet, the next Ethernet is the fast Ethernet. Ethernet specification is given by the IEEE, that is 802.3, that is the MAC frame format. Next is the fast Ethernet, which is 802.3U. It is different from the traditional Ethernet in case of the data rate. It can transmit the data 10 times faster at the rate of 100 Mbps. So the goal of Ethernet can be explained. The fields are almost same, only the data rate is different. So in this, we simply upgrade the data rate to 100 Mbps. It is totally compatible with the standard Ethernet. We can use the standard Ethernet with this. So it will keep the same 48-bit address. It will keep the same frame format. It will keep the same minimum and maximum frame length. So the difference is only in case of the transmission rate in the data rate. So 100 Mbps is transmission rate in case of the fast Ethernet. We can combine the 10 Mbps, that is the traditional Ethernet, and the fast Ethernet, which is having the 100 Mbps data rate, on the same network. And for connecting these two different that is Ethernet and the fast Ethernet, we have to use some connecting device, and we can connect these two on the same network by using switch. Media which is used, that is twisted pair or fiber optics cable we can use to connect, and the star wire topologies we can use. So this is the fast Ethernet. This is the table of fast Ethernet for the implementation. First cable, that is 100 base T4, and cable is twisted pair. Approximate maximum segment is 100 meter. Next is 10 base TX, which is also of twisted pair, and approximate maximum segment is the 100 meter. Next is the 10 base FX fiber optics type, and approximately maximum segment is 2000 meter. Now the fast Ethernet implementation. In the fast Ethernet implementation, these three things are used. Three different type of wires are used. First wire is the 10 base TX, that is 2 wire category 5 of UDP, that is the twisted pair, unshaded twisted pair. Next is 10 base FX, 2 wires for fiber, and 10 and 100 base T4, that is 4 wire of category 3 UDP, that is unsheeted twisted pair. So these are the three different implementation wires for the fast Ethernet. Next is the gigabit Ethernet. In gigabit Ethernet, we give the standard, that is 802.3Z. So it is almost same with the standard Ethernet and the fast Ethernet, but only the data rate is different. So it will upgrade the data rate to the 1000 Mbps, or we simply say 1 Gbps. So make it compatible with the standard Ethernet and fast Ethernet. It will keep the same 48-bit address. It will keep the same frame format, same minimum and maximum frame length. So the speed is only changed, that is become 1000 Mbps or 1 Gbps, and the minimum frame length is the 512 bytes. We can operate this gigabit Ethernet into two modes. One is full duplex or half duplex. Mostly it is used in the full duplex, means both can send and receive the data at the same time. Now the implementation, 1000 base SX means the fiber optics type of cable, and maximum segment is 550 meter. Second is 1000 base LX fiber optics type of cable, and approximate maximum segment is 5000 meter. Next is 1000 base CX 2 pair of shaded twisted pair, that is STP. So approximately segments is 25 meter. Next is last is 1000 base T 4 pairs of UDP and approximate maximum segment is 100 meter. Next is the gigabit Ethernet implementation. The four different type of wires can use. First wire is the 1000 base SX, which is the two wire short wave fiber optics. So it is the type of fiber optics, but in this the short